Okay, let's go ahead and look at this example here. This example involves some sprinklers. We've got two irrigation sprinklers that spread water in circular paths with radii of 7 metres and 4 metres. We're told, if the sprinklers are 10 metres apart, find the area of the crop that receives water from both sprinklers. So let's start this with a diagram. So we'll make this one our 7 metre sprinkler, and let's bring in another one, and that will be our 4 metre sprinkler. In this question, we're interested in finding this overlapping area. And let's put in some extra lines so we can start imagining what that looks like. I am sort of looking at that, and I think it would be really useful if we drew a line that goes from here to here. Oh, it's slightly crooked, everyone. I'm sorry about that. And then hopefully you can see that this shaded area here is a segment due to the purple 4 metre radius circle. And then we've got this segment here that is a segment due to the pink circle being bounded by that blue chord that we've drawn in there. So what we have is two segments here. And to be able to find the area of these two segments, we're going to have to find the angle that's subtended by this chord. So in order to do that, on my sketches, I'm going to put where the origin of each circle is. I don't have to label it O. You could if you wanted. You maybe need O and O dash because you've got two different circles. But that's maybe being a bit pedantic. Now, to find the angle of interest, we are going to have to get our ruler again and draw a line from the point of the center of our circle to the ends of the chord. And of course we know, because this is our 7 metre circle, that this radius would be 7 metres, and these two lines are equal because they're both the radius. Let's now draw one for the 4 metre circle. So these lengths here are both 4 metres respectively. Now you might like to draw sort of zoom in of this, but you know, power of technology, I can do this. Now there's one piece of information that I haven't included on my diagram here. We're told that the two circles are 10 metres apart. Sorry, the two sprinklers. So that means the centre of each of these circles is 10 metres apart. So as I sit here wondering how to do this problem, I notice that we have, I'm just going to highlight it in yellow, formed a nice triangle here where we know 3 of the lengths. I think that would be really helpful to be able to find 2 angles. Let's call this angle alpha, and we'll call, what's another colour I haven't used, we'll call this angle beta. And using that triangle and the cosine rule, because we have 3 known sides, we've got the 7 metres, 4 metres and 10 metres, we can use that to find these 2 angles. And then we'll know that this total angle here is 2 alpha. That will help us find the area of that segment. And this total angle here is 2 beta. So let's go ahead and work with this triangle. I've just labelled the vertices A, B and C here for when we use our cosine rule. If we're interested in finding angle A, which we've called alpha, we didn't really have to call it alpha, I just really wanted to use a Greek letter. We would need to use the version of the cosine rule that starts with A squared equals B squared plus C squared minus 2BC cos A. And we're going to rearrange this to get cos A as the subject. So hopefully you can see that would be B squared plus C squared minus A squared on 2BC. So this means that A will be the inverse cosine of this. I like to do my algebra before I substitute because it just means, you know, it's a little bit cleaner. And that was equal to alpha, but we actually want to find 2 alpha as we had in this diagram here. So we could multiply both sides by 2 here. So it's going to be 2 lots of the inverse cosine. Now let's go ahead and actually substitute what we've got in here. Side B is 7, so 7 squared. Side C is this one, which was 10 squared. And side A minus 4 squared on 2 times 7 times 10. Okay, let's go ahead and put this into our calculator. I like to use the fraction template. Shortcut to find that was Shift Divide. And we're just going to type in the values carefully here. And you could just use like a decimal approximation here. So 2 alpha approximately equals, or you could just write equals 36.389 ... We're not rounding here. we're signifying that that angle keeps on going. Ah, but I've made a critical error here. This would be in degrees, but we actually want, when we're using these formulae, for theta to be in radians. So let's change this to radians. GRA is another unit that you can use to measure angles, but we won't be using it in our course. Putting that into radians, we get 0.635 ... radians. Using the same approach, let's go ahead and figure out what 2 beta is. So you're going to be using the same triangle again, but you're going to be looking at the cosine rule using this angle here. I'm going to do this working out, but a little sped up, and let's see if you get the same thing. You're welcome to pause the video and see if you do. Okay, now that we've done that, and just a point to note here, you don't need to put the approximately equal to signs here. I was sort of having a think about it while I was doing this. You're more than welcome to just put equal signs because you've got the ... so it's clear that, you know, it's not just an approximation that we're doing here. So if you didn't like them, that's fine. If you do like them, I don't mind. I'm not going to be marking you incorrect or correct for that. What will bother me, though, is if I leave that as black when I had it as purple before. Okay, so now we're just going to be using this segment formula twice. We're going to be using the pink segment that we use for 2 alpha, and the purple segment we're going to be using 2 beta. I'm going to go ahead and do 2 alpha on the screen, and 2 beta, I'll just do it and give you the answer. I'd really like it if you could pause and compare your answers to mine. Now you might have seen I got a negative for my answer then. When I checked through what I'd done on my calculator, I realised I'd accidentally put in inverse sign instead of sine. So that's one thing to keep in mind. So that's 1.02 ... meters squared. I'm going to just keep that whole number in my calculator. I'm going to go ahead and find the other measurement now. I'm not going to do the working out. I just want you to compare it to what you've done. Okay, and I get 1.92 ... meters squared. So therefore, total area, keeping those 2 values in our calculator, we'll just add them together. And now we can round it. Has it asked for a particular rounding? No, it hasn't, but we could write that as, let's do it to 2 decimal places, 3.08 meters squared. I just wanted to see if there was a standard answer that was nicer, but I don't expect you to write a fraction like that. So that looks like a fine answer for this question.